All right, yo, back with another one. Let's get some homework knocked out. Now we're doing substitution method for the 3 variable systems. All right, number 1. So the idea, z is already solved, x is already solved, so we're going to use that to our advantage. Z or x really doesn't matter, right? So z, since it's already solved, all of this, negative 3x minus 1, is going to get substituted into z and into z. And then noting, something to note, this has to distribute. The negative has to distribute in the bottom one. In the top one, the negative 3 is going to have to distribute. So anytime there's a negative, you're definitely distributing the negative. For sure, for sure. You don't necessarily distribute a positive one, right? Because anything times 1 is just 1. Or anything times 1 is itself. But anything times negative 1 definitely changes it. So we'll do that. So we'll do the top one first. Negative x minus y minus 3, open parentheses, 3x minus 1 equals negative 9. All right, distributing, we get negative x minus y plus 9x plus 3 is equal to negative 9. Combining like terms, so negative x and 9x, 8x. Negative y, and that's it, negative y. So minus y, I'm going to subtract 3 from both sides. So this is negative 12. 8x minus y equals negative 12. Okay. I'm going to substitute z into the bottom one. We get x equals 5y minus negative 3x minus 1 plus 23. Distributing the negative, we get x is equal to 5y plus 3x plus 1 plus 23. Combining on the right, we get 24. I'm going to subtract 3x from both sides. That's going to make negative 2x is equal to 5y plus 24. And then lastly, subtracting 5y from both sides. So I'm going to get negative 2x minus 5y equals 24. Okay. From here, this is just like the elimination method, basically. This is going to be 6x well, actually, we have to eliminate something. I mean, I guess technically, to be technical, right, we want to keep substituting. So, I mean, I can add y to both sides, and then I can add 12 to both sides. So really, we're going to get 8x plus 12 is equal to y. Then I'm going to substitute this into here, into the y. So this is going to be negative 2x minus 5. This is going to be 8x plus 12 equals 24. So distributing the 5, negative 2x minus 40x minus 12, 24, 36, 48, 60 equals 24. Negative 42x plus 60, right on both sides, is equal to 84. Dividing both sides by negative 42, x is equal to negative 2. I'm going to plug that back in to here to get y. So that's going to be, I'm running out of room. That's going to be 8x, which is negative 2 plus 12. This equals y. So negative 16 plus 12 equals negative 4. So y is equal to negative 4. And finally, z, well, I can plug in x into the middle one. So this is going to be z is equal to negative 3, negative 2 minus 1, which is positive 6 minus 1, which is 5. Z is equal to 5. Right, positive 6 minus 1, 5. Okay, so that was substitution method. Substituting the entire way. I mean, right, do you have to do substitution the entire way through? It's debatable. Okay. Let's try it again. Let's see where this takes us. Again, y is already solved. So we're plugging 5x plus z minus 4 into y. So all this goes here. And notice there's no y term in the top. That might play a role here in a little bit. So negative 5y. In this case, y is going to be 5x plus z minus 4 minus z equals 25. Distributing the 5, the negative 5, we're going to get negative 25x minus 5z plus 20, and then minus z is equal to 25. Combining the things on the right, what do we have? We have a z. So negative 25x, right, that's it. 5 and z make negative 6z. I'm going to subtract 20 from both sides. So equals 5. All right, that's it. Box this so we don't lose it. Can I plug in to the other one? That's the question. There is no y. So what can we do? We got to get it down to one variable. That's what we got to do. So since this is already solved for x, we can plug it into this x. So this is going to be negative 25. I'm going to plug in, substitute, negative 4z minus 19 minus 6z is equal to 5. Right? Because there was no y in the first equation. So I can't do anything. So I need to get this down to one variable. Since it was already solved for x, we're plugging it into the blue boxed one. In fact, that's the only place we could plug it into because there's no x in the bottom one. So it's like we're almost forced. So this is 100 z 25 times 19. Great. So this is going to be 9 times 5 is 45, 18, 19, 20, 21, 22, 5, 2, 5, 7, 475. Positive 475 minus 6z is equal to 5. Combining the z's, 94z plus 475 is equal to 5. I'm going to subtract 475 minus 475. So 94 equals negative 470. Ooh, oh, can't see it. All right, this one's kind of rough. So thinking, right, I got to multiply this by something. This is a z. 5 times 4 is 20. That's the only way to make a 0. Other than 10, right? Like if I multiply it by 10, that's 940. So if I multiply it by 5, 94 times 5 is going to be 20, 45, 46, 47, 470, exactly. So z is equal to negative 5. Okay. Where can I put that? I'm going to plug that into the blue box to solve for x. So negative 25x minus 6z, which is negative 5, equals positive 5. This is negative 25 plus 30 equals 5. Minus 30. So negative 25x equals negative 25. That's nice. X is equal to 1. So now we need a y value. Since z is negative 5, we can plug it into the bottom equation. So this is going to be negative 5y minus z, which is negative 5, equals 25. So negative 5y plus 5 equals 25. Subtracting 5 from both sides. Negative 5y is equal to 20. Divide both sides by negative 5. Y is equal to negative 4. So x, y, z. 1, negative 4, negative 5. Can't see it. 1, negative 4, negative 5. All right, number 3. Again, y and z are already solved. If we substitute this into z, let's see what happens. So z, not z, y is equal to x plus z, which in this case is negative 3y minus 3 plus 5. Right, all we did was substitute this in for z. Okay, combining things on the right. X minus 3y. Well, I'm pretty much dropping the parentheses because there's a plus in front. Minus 3 plus 5 is going to be positive 3. No, positive 2. Right, negative 3 plus 5, positive 2. If I add 3y, I get 4y is equal to x plus 2. Then subtracting y, I'm going to get 4y minus x is equal to 2. Okay. What could we do? What could we do? All right, so I'm thinking this and this somehow is going to go together. Here, if we solve for x, right, if I solve for x, meaning, I'm going to back up a step actually. Because here when we moved everything to one side, if we solve for x here, minus 2, 4y minus 2 is equal to x. Now, this can go into there. So this is going to be 2. X in this case is going to be 4y minus 2. Minus y equals negative 4. Distribute the 2. 8y minus 4 minus y is equal to negative 4. So this is going to be plus 4, plus 4. That's nice. And then combining the y's, we get 7y is equal to 0. Therefore, y is equal to 0. Okay, I need to plug that in somewhere to solve for x. So going into here, this is 4 times 0 minus 2 equals x. Or in fact, this should be boxed because that was the whole key. So it's 4 times 0 is 0. Minus 2 is equal to x. So x is equal to negative 2. So now we have an x and a y. We just need a z. So the middle equation is already solved for z. So z is equal to negative 3y, which is 0, minus 3. Z is equal to 0 minus 3. Therefore, z is equal to negative 3. Okay, so substitution, we can see gets a little involved. Like, it's very logical, super logical, right? What do I have? Where can I sub it into? So unlike the elimination method where you have to use some sort of, well, I mean, you're still using logic, right? But you're having to play like a guessing game or like a very analytical, right? Like, oh, where are the signs that different, but the number's the same? And then like, right, like it's very analytical. Here, you're just subbing in. Just solve for a variable and sub it into one of them. Truly doesn't matter which one. Like, it really does not. All right, so let's see. Number 4. Y is by itself and x is by itself. So I think if we, well, really there's only one thing we can do, right? X can only go into one spot. That's the only place x can go. So we're kind of forced. So let's just do that. So y is equal to negative 5x, which is 4z plus 4 minus 4z minus 5. All right. Distributing the negative 5, y is equal to negative 20z minus 20 minus 4z minus 5. Combining on the right, the z's, So y is equal negative 24z. Negative 20 and negative 5 combine to make negative 25. Okay, so notice y is by itself. We have just a z. Top equation has a y and a z. So all of this is going to go into the y in the top. Now, if you think about that and be like, okay, well, why? Why is it going there? Well, it can't go into the bottom because there is no y. And then it can't go into the middle one because literally that's the one that we're working with. Like we just subbed into that one. So it's got to go into, it can only go into the top. So this is going to be negative 2y, which is negative 24z minus 25 plus 5z equals negative 3. Distributing the negative 2, we're going to get positive 48z plus 50 plus 5z equals negative 3. Combining 48 and 5, 53. Z minus 50 from both sides. This is equal to negative 53, which is nice. Like, it's nice when it just works out. Z is equal to negative 1. So Z is equal to negative 1. Okay. I can plug that in here to figure out what Z is. I mean, I know what Z is. I can plug that in to figure out what X is. Furthermore, we could plug it into here. Oops. We could plug it into here to figure out what Y is. So I can get X and Y right now by plugging into these two equations. I need to glance up more. Okay, so this is going to be X is equal to 4, negative 1, plus 4. And then, just for grins, right? Y is equal to negative 24, negative 1, minus 25. Just knock them both out. This is going to be X is equal to negative 4 plus 4. That's nice. X is equal to 0. Then we have Y is equal to positive 24 minus 25. Therefore, Y is equal to 1. So X, Y, Z, 0, 1, negative 1. 0, 1, negative 1. Okay. Let's see what's happening. So number 5, Y is by itself and Z is by itself. Let's plug all this into Y. Well, technically it can only go one place, right? It can only go one place. Here. Then I'll be left with nothing but X's and Z's. And then we'll plug in the Z. So let's solve this one first. This is going to be 4x plus 3y, which is x plus 4z minus 5. Minus 5. Oh, no, minus 5. Minus 2z equals 5. My bad. All right. Distributing the 3. We get 4x plus 3x plus 12z minus 15 minus 2z equals 5. Okay, combining all the things, like terms. So 7x plus 10z. I'm going to add 15. So equals 20. 7x plus 10z equals 20. This is our important piece. So now, this z, right, z is equal to negative 2x plus 2. So that z, that's going to go into here. So we're going to get 7x plus 10z, which is negative 2x plus 2. Equals 20. Distributing the 10, 7x minus 20x plus 20 equals 20. So this is going to be negative 13x. When I subtract 20 is equal to 0. Therefore, x is equal to 0. That's nice. Oh, keep doing that. My bad, y'all. X is equal to 0. So I can take that x, plug it into here to get z, right? I can get z. If you don't like that one, you could plug it into here and get z. That one's probably better. X has to go somewhere, right? You have to plug it in somewhere in hopes to solve for a single letter. So you can choose whichever one you want. So z is equal to negative 2 times 0 plus 2. Z is equal to 2. That's nice. And we can see with some quick mental math, that's the same thing that would have happened over here. X would have made the 7 go to 0, and 10 times what equals 20? Obviously, z is equal to 2. Okay, now I need a y. So we can plug both of these, x and z, into the top path, or top equation. So negative, or y is equal to x, in this case is 0, plus 4 times z, which is 2, minus 5. So y is equal to 8 plus minus 5. Y is equal to 3. That one was fun. That one was fun. Okay. Number 6. All right. X and Z are by themselves. So this really isn't clear. However, this Z, it can go here and here. I think I'm going to do that. So let's work the top first. So this is going to be X equals 3y minus 3z, which in this case z is 4x plus 5y minus 14 plus 8. Okay, distributing x is equal to 3y minus 12x minus 15y plus 3 times 14. So 3 times 15 is 45. 45 minus 3, 42. Positive 42. Plus 8. Okay. Let's clean this up a bit. Combining the things that are like the y's. So x is equal to negative 12x minus 12y plus 50. Okay, what I want to do, let's move the 12 over. So this is going to be 13x is equal to negative 12y plus 50. That's not useful. Okay, that's okay. Because now we're just going to put this on the back burner. We're just going to box it. Now I'm going to work the bottom equation. I'm going to plug the same z into the bottom equation. This is going to be 3y plus 2z, which in this case is again 4x plus 5y minus 14. Equals 14. Right, all I did was plug it into the bottom. Distribute. We get 3y plus 8x plus 10y minus 28 equals 14. All right, on the left, we can combine 10 and 3. So 13y plus 8x. I'm going to add 28 plus 28. So it's equals 38, 39, 40, 41, 42. Okay, this is wild because here we have the 2. So I'm not going to try to substitute again. Right, because if I solve for x, we're definitely running into a fraction. And we try to clear the fraction, we're multiplying by 13. All right, so let's just stick to what we know. I'm going to get all the x's and y's on the same side. So 13x plus 12y is equal to 50. I rewrote the black box. Then I'm switching them around to 8x plus 13y is equal to 42. Okay, this isn't better either. I'm still multiplying by 13. So really, do I want to substitute and run into fractions? Okay. Let's do I'm hesitating because I don't want to do this. Okay, so negative 13, 12, right? Coming from the elimination method. I could stick with substitution, but, why? I already substituted twice, and look where it got me. Okay, so this is going to be negative 169x plus what's 13 times 13? 9, 3, 4, 3, 1, 9, 4, 5, 6, 7. Is that true? There is no carry of the 1. 9, 3, So yeah, 13 squared is 169. Duh. So what's 12 times 13? Well, 12 times 12 is 144 plus 12. 156. Right, because 13 times 13 is negative 169. 13 times 12 is 156, right? 12 times 12 plus another 12. That's basically what I just did right here. So that's going to be 156. It's negative 156y equals 13 times 50. So that's going to be 650. Okay, 12 times 8, 96 plus 156y, 42 times 12, 4. Sorry, you can't see. 4, 8, 0, 2, 4, 8, 9, 10, 504. Hope that's right. 504. All right, so when we add, oh, look, I'm about to make a mistake. The 13 times 50 is going to be negative. This is negative 650. Okay, so when we add 169, negative 169 plus 96. 73 negative, cancels, and we add, we're going to get 6, 14, negative 156. No, 146, I'm sorry. And that's nice because look, negative 73, negative 73, x is equal to positive 2. That's, man, that one's intense. So let's put that somewhere. So that can go into here to solve for y. So this is going to be, or it can go here to solve for y. It truly doesn't matter. Which one's better? Let's do the left one. Let's plug it in here and solve for y. So 13y plus 8 times 2. I'm just going to do the math right now. 42 minus 16. So 13y is equal to 626. Y is equal to 2. So now I have a x and a y. We just need a z. I'm going to take y and plug it into here. Right, this one will give me a z. So 3 times 2 plus 2z equals 14. This is going to be 6 plus 2z equals 14. Minus 6 minus 6. 2z is equal to 8, which z is equal to 4. So x, y, and z. 224. Okay. We're at the bottom. 2 to go. Let's get it under an hour, please. Okay. This z going to go there and there. So top path, or top equation, negative 5x minus 3y plus x plus 5 equals negative 4. So that's negative 5x minus 3y. Actually, combining like terms will be negative 4x minus 3y minus 5 equals negative 9. Okay, I'm boxing that so I don't lose it. Then the middle one. Look, they're all 2's. Could I factor out? Could I factor out a 2 and make life easy? Will it make life easy? Let's factor out a 2. So then that's going to be negative x, negative y, plus z equals 2. Right? All I did was divide everything by 2. So now this z is going here. So negative x minus y plus z, which is x plus 5, equals 2. Combining like terms. Oh, that's nice. X's cancel. Minus y minus 5 is equal to negative 3. Therefore, y is equal to 3. To figure out what another variable is going to be, let's plug this into here. So that's going to be negative 4x minus 3y, which in this case is 3. And equals negative 9. So negative 4x minus 9 equals negative 9. When I add 9, negative 4x is equal to 0. Therefore, x is equal to 0. So I have a y and I have an x. So now I just need a z. So let's plug x into here. And that's nice because z is equal to 5. So x, y, z, 0, 3, 5. Someone needs to check the key and tell me if we're right. If we're not running in the fractions, then I'm running with it. And it seems to be working out. Right, when numbers work out nice, that's a good omen. Okay. All right, y is already solved, but nothing else has a y, so y can't go anywhere. How unfortunate is that? I'm going to rewrite these. Like, can you notice that they're all even numbers? I'm going to make the numbers smaller just to make life better. So I'm dividing by 2. So negative 2x plus z is equal to 7. And then negative x minus 2z is equal to 11. Okay, so here I'm going to add x and subtract 11 from both sides. So cancels. So this is going to be x is equal, right, because x is all alone on the right. So x is equal to negative 2z, negative 11. Okay. I got a plan. X is equal to this, right? It's going right there to solve for z. Solve for z. We're going to get negative 2. X in this case is negative 2z minus 11 plus z equals 7. Distributing, we get positive 4z, positive 22 plus z is equal to 7. Combining on the right, we're going to get 4z is equal to 24. 4z plus 24 is equal to 7. Moving down, 4z is equal to 7 minus 24. What's 7 take away 24? It's going to be negative for sure. I don't like it. I don't like it. It's a number I don't like. It's not 13. 17. It's even worse. Right? Because 7 is 4 and 3. So 20 minus 3, 17. So let's see. Let's double check what happened. So 2 negative x negative 2 equals 11. I added x. I subtracted 11. So negative 2z minus 11. All right, up top we had 2x plus z equals 7. So I divided everything by 2. When we plugged in to x, right, because x is negative 2 is positive 4. Negative 2 times negative 11 is positive 11 plus z. Oh, wait, the plus z. That's where it was. That's where it was. I even struck my z too. That's crazy. Okay, so here, 4z plus z is 5z. Come on, bro. So this is 5z equals 7 minus 22. Right, that's a z. Okay. So 7 take away 22. That's better. That's negative 15. Divide both sides by 5. X is equal to negative 3. Still on the screen. Good. Okay. I need to figure out what z is. So let's put x somewhere. I'm going to put x right back into here. So negative 3 is equal to negative 2z minus 11. So add 11 plus 11. 11 take away 3, 8 equals negative 2z. Negative 2, negative 2. Z is equal to negative 4. So now I have an x and a z. Where can I get a y from? Is there an easy one? No, there's only one spot, the middle equation. So y is equal to x, which in this case is negative 3, plus z, which is negative 4, plus 12. So y is equal to negative 7 plus 12. Y is equal to 5. So negative 3, 5, negative 4. All right, hope you guys enjoyed.